Hi, I'm Pat Kelly. Okay, in this problem, I have a little bit of work to do. They're asking us to find the least squares regression line. They do tell us to use a graphing utility to verify our work, but we're not going to do that until we actually do our work and get an answer. And what it really comes down to, I think, the work for this is this system of linear equations. It's kind of like a formula for us. So you'll let this guide your work. So I doubt you're memorizing this. It depends on your teacher. But if you get this system, if it's given to you, let that steer what you need to do. I say all that because you can also see that I have a table ready to go. But even in terms of what to set up in your table, I would make that decision. I would make those decisions based on this formula. In this formula, I can see that I need the sum of the x's and the sum of the y's. That's what the sigma is. I also need the sum of the x squareds and the sum of x times y. Notice that's what would have motivated me to make my table have a column of x's so that I can add them and put that value right there and also right there. I have a column of y's. I'll add that column to put into sigma y in the formula. I have a column for x times y I can then add for that part, and then x squared I can add for that part. Okay, so it's not as involved as it looks. Let's now get to this table so we can do those summations and then fill in this formula. We'll still be left with a system of linear equations we need to solve in terms of a and b, but we'll do that. Okay, so my original data, I went ahead and put the x's in the first column and the y's in the second column. Let's fill in the other two columns. X times y is just multiplying, 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 multiplying. And the last column is x squared, so just square this first column. 16, 9, 4, and 1. Okay. Then again, the motivation for this whole table is that I can then add, and that's what I'll do down below each of these columns. So minus 4, minus 3, minus 2, minus 1, add them up, and I'm getting a minus 10. 1, 3, 4, and 6, that looks like a sum of 14. These are all negative, but what am I looking at? 14, 18, 27, negative 27. And then this last column looks like a 30. Should check me on that. You can always use a calculator. But again, those values I did just because I now want to put them into my formula. Like here and here, 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 and here. Okay. One last piece of the puzzle that's missing is n. And n is, as it always is the number of data points you have. Okay, so 1, 2, 3, 4. Let's get into our work here and fill in 4 for n, 4 for n, and it's times b, plus, now for this sigma x, I'm replacing it with the minus 10 that was the sum of my x's. So minus 10 times the a that we're going to solve for, equals the sum of the y's, that was 14 for me. Second equation, the sum of the x's again, that was the minus 10. That's supposed to be multiplied by this unknown b that we'll solve for, plus the sum of the x squareds, that was my 30, times the a in the formula, equals the sum of the xy's, which was this column. Looks like a minus 27. Okay? So I hope getting to that point, it's not as bad as it might look. You're just filling in those summations from your table. And now it's a system of linear equations. You just have to solve for a and b, which we'll do. Okay? Grab even another color. What I would do probably is match these coefficients of a by multiplying that first row by 3, I think will work. So I multiply by 3 and I get 12b. This is a minus 10, now it's a minus 30a. Multiply by 3 and I get 42. Because what that allows me to do is combine these two equations conveniently because those a terms are just going to cancel each other out. So minus 10b plus 12b would give me a 2b. Those a's are gone. On the other side of the equal sign, a negative 27 plus 42, that looks like 15. So I can now solve for b as a 15 halves. All right, I think that looks good. Then we take that value of b, maybe I'll even switch up colors here, use that in this, I think I'll grab the top equation. You hopefully remember it doesn't matter which equation you're going to grab in order to solve for a. I like this one with the smallest coefficients. So 15 halves times the 4, do a little bit of arithmetic in my head, the 2 and the 4 will divide out to a 2 times 15, that looks like a 30. The b's gone, that's what we just plugged it in as, and then minus 10a equals 14. Let's throw the 30 to the other side, minus 10a. Subtracting 30 looks like a minus 16 over there, one step away. Divide over the negative 10, and I'm getting a positive 8/5. All right, good. Pat yourself on the back. What that tells me, let me see, I'll grab orange. That tells me my final answer is that least squares regression line. So you should have some kind of y equals mx plus b expression, right? And that's the point of the a and the b that we solved for, is the a is your slope, 8/5 times x, plus, it's positive, right? Your b is the intercept, so 15 halves. And this would be my answer for that least squares regression line. I like it. The directions did say to verify with a graphing utility, so let's see if the calculator gets it right, or the graphing utility. I'll grab mine. Okay, now I have to put my data in to two different lists, the x values in one list and the y values in a second list. This will depend on your graphing utility. But I have my x's in one list, my y's in the second list. And then I go to some kind of statistical feature depending on your graphing utility. For me, I have to go to stats and then calculate and find linear regression in the menu. Your graphing utility should be comparable. Linear regression, and you do have to specify where your data is. Mine is in my first two lists, so those are labeled L1 and L2 for me. Separate with a comma. Again, depending on your graphing utility. All you have to do now is hit enter, and I'm seeing the equation or the values of A being 1.6 and B being 7.5, which are the exact decimal equivalents of those fractions. So we got it right. I knew that. The graphing utility got it right. Practice some more on your own, okay?